Welcome to the next stop on the 2021 launch event. My name is Tom Watkins and I work for SolidPrint 3D. So, who are SolidPrint 3D? Well, we are Solid Solutions' sister company who specialise in scanning, 3D printing, desktop CNC machines. So not only that, we're going to give honest advice on how these machines can help your business and then provide the technical support and training to go alongside them. So if you want to know about the process we can use to basically find out if we can assist you, so we'll give some design for additive manufacture advice for your individual part files. We can then look into some test prints for you and then use these to create a return on investment study. So how have we actually helped out customers before? Well, we did a video quite recently with S&G Barrett. They produce parts for classic Jaguars. If you want to check out this video, it's on our website. Because today instead we're going to run through a bit more of a different case study. This is one we've done quite recently with Joe Townsend of JT Custom Adaptive. He's a Paralympic athlete who came to us looking for some assistance on how he can 3D print his bespoke end-use parts for his bike and also his customers' bikes as well. So without further ado, here's the sit down I have with Joe, going through who he is and what kind of parts he's going to be printing and using on his bike.
Okay, yes, well, my background is former Royal Marines Commando, and I got blown up in Afghanistan in 2008 while serving the 40 Commando out there, which resulted in me losing both of my legs. And then kind of throughout the rehabilitation process, heavily caught, I started trying different adaptive sports as kind of a way and a means to kind of get active again and give myself some drive in life and kind of allow me to do something that kind of made me feel physically active and feel good about myself. And kind of through trying all these different sports, I found triathlon. And then in 2011, we were challenged as a team of injured servicemen to take on an Ironman triathlon, which is 2.4 mile swim, 112 mile bike and a marathon. And kind of signed up for that. Managed to complete my first Ironman in Bolton in 2011, and then was kind of hooked on triathlon from there. So I kind of went on, did various Ironman triathlons, did the race across America twice, so some pretty cheeky endurance events. And I was just absolutely loving the sport, loved the freedom that I had when I was on the hand bike. The fact that I could go out, although I'm driving it with my arms, I pretty much kick the arse of any of my able-bodied friends on a bike. So it was a good feeling to kind of bring that level playing field back, and your disability kind of becomes irrelevant at that point. And then, as time went on, I was loving life, training full time. But I kind of realised that it's great doing all these challenges and activities, but actually I'm an adult and I need to think about going back to work and getting a job at some point. But then I found out that para triathlon was going to be on the cards in the Paralympic Games for Rio 2016. So that opened up a window for me to compete the sport I loved at a competitive level and obviously get paid for it. So I kind of set my sights on that. And I think it was 2013 I was accepted onto the squad for Great Britain, and been racing para triathlon ever since. Been to Paralympic Games in Rio, Commonwealth gold medalist from Gold Coast in 2018, and then all aspirations have been to go towards Tokyo for 2020, 2021, 2022. Who knows what's going to happen? Yeah, it's a big thing for me, pretty much since day one, has been a lot of adaptive equipment. Bits are taken from existing parts of existing bikes, existing mechanisms, and basically plonked and made to fit for a hand cycle or a racing wheelchair, for instance. And I mean, these pieces of kit aren't cheap. Bear in mind, when I travel to a race, I've got nearly 25 grams worth of equipment with me. And when you're kind of paying that amount of money for equipment, you want it to be purpose made for the job it's intended to do. And you want items on your bike which are not giving you a massive weight penalty, are going to be as aerodynamic as possible, and make the bike as fast, as stiff, and as strong as possible. So obviously as athletes we train our asses off and we push ourselves physically as much as we can, but at the same time if we can improve our equipment, then there's gains and there's progress we have from that as well. So I've been kind of really keen on the equipment optimization, and that's why I think 3D printing is so great. It's really hard to kind of group athletes with disabilities into a category when it comes to disabilities, because people's bodies are so varied, people's functions are so varied, and people's requirements. Whereas with 3D printing, it's so easy to make one-offs or just really small production runs, or make an item on a file to draw it in CAD, which is roughly a generic size, which then can be pretty quickly adapted to fit someone as they would require it, and then manufacture it pretty much instantly. You wouldn't be able to do that through kind of any other production method really, without having massive costs and expenses, which then just makes everything prohibitive for the athletes. And you get something like a road bike road lever, like SRAM or Shimano. I've had that in a wind tunnel. They've spent thousands on it in research and development. But then you put a bracket on a hand bike, stick it on sideways, and it's pretty crap into the wind. It serves a purpose. It slows the bike down, but it also slows it down when you're going into the wind. So being able to make short production runs of things which are bespoke made to fit onto the bike is going to have a function, aesthetic and aerodynamic advantage, as well as hopefully weight. So it's kind of exciting to be able to do this now, because obviously, as you know, 3D printing was fairly locked down to very few. It wasn't accessible not that many years ago, whereas actually with the patents being lifted and the technology moving on and companies bringing out new kit, being able to make it more accessible to more consumers, to be able to make such bespoke short run items. Most of the ideas which I've come up with myself, but I know the sport very well. I've been immersed in it for so many years, and I know what shortfalls are. So I'm solving problems for myself, but at the same time, I know that if I'm having these problems, other athletes are having them as well. And I think that's why people have been so receptive to the grips. It's something I've been trying to achieve for quite a few years, and I spoke to several universities and several businesses about basically recreating what I've done. And people are generally either uninterested, incapable of doing it, or the price was just too prohibitive. And I think that's really where the 3D kind of printing market and technology has moved on so well. That if I'm able to do this at home with no engineering experience whatsoever, and kind of just self-taught myself to be able to do this, it means I can open up an avenue and provide parts for athletes at a much, much greater reduced price than what they'd have if they went to a company which are experts in this. And generally, from what I found, for a company to take on just an individual one-off part, it's just too prohibitive cost-wise for the athlete to be able to do it. So it's nice to be able to open up that avenue and solve things for people and make their lives and their equipment better. So basically, what I've been doing is making custom hand grips for the bike, and I'll 3D print a base shell, which is kind of the shape of a typical bike handle, but a little bit smaller, just out of cheap PETG. And then I send it in a kit with some thermoplastic pellets, which you can heat up in hot water, and you can mold that and shape that to kind of any shape you want. So I get the athletes to mold that around their hands and make a grip for them, which is completely bespoke to their hands and to their needs. And then they can try that on the bike whilst they've got the mold there. Using a heat gun or hot water, they can make fine adjustments. And then once they've got their grip exactly how they want it, they send that back to me. I mean, I can scan that onto the computer, make the edit, do the cutouts, the bearings, the spindles, which are going to go through, and then print those ready to ship out. Yeah, and that's it. I mean, you look at top end road bikes and the amount of time they're spending in wind tunnels and how tidy they are with cable management, and you're paying a similar price for, if not more, for a hand bike or a racing wheelchair. And you've got a lovely frame, it's stiff, the cage is made beautifully to fit you. I mean, you've just got a whacking great chunk of aluminium tube hanging off the top of it to steer it. And yeah, frankly, it's ugly and it's not great into the wind. So yeah, it's kind of excited to look at improving these and kind of getting them out there. Yeah, I think I've got 10 pairs of grips currently out worldwide. I'm getting orders fairly frequently at the minute. And just started moving into racing wheelchair gloves as well, um, which is another technology which these are bespoke made to the individual athlete, and generally they're made out of the aquaplast, the thermoplastic, which is great for being able to mold the shape of your hands and then get the perfect racing wheelchair glove. But it also has its downsides in that it's heavy, it melts in the sun, and if you break it, it's near impossible to replicate an exact same glove. Whereas actually with being able to take a mold, I mean, have the print scanned and saved onto your computer, you can have 2, 3, 4, 5 pairs of the exact same glove, and you'll know that it's always on file. So if you break one, if you lose one traveling to a race, for example, you can have spares and you can always get another pair printed off. So for disabled athletes, it's a real game changer. It's hard to explain to people how important these gloves are, but when you've made something which fits you like a glove, excuse the pun, and you know how you push on that glove and it is personal to you, when you try pushing on the glove, which is slightly different, it just feels different and it throws you off your push. So I know it can literally make a difference between being competitive at races and not. So to be able to have flexibility of having your gloves scanned on file and be able to have multiple pairs printed off, pairs set up for the wet, pairs set up for the dry, pairs for training. It's a huge kind of advancement for us. As I say, it really is kind of, I don't want to say life changing, but the amount of worry I had with my racing wheelchair gloves, like you go to a race and as I say, I've got a habit of collapsing across finish lines. When you end up in a medical tent for an hour after the race and you come out and all your equipment's gone, somebody's taking it back to the hotel there for you. I mean, you can't just like, oh, where's my gloves? I think it was in Rio actually. I lost one of my gloves after the race, and all you're thinking is, oh, like, I've got a race after this, and I don't have a replica of this. Luckily, it did turn up at the race venue. It had been dropped, but yeah, it's just a worry. And as an athlete, you've got enough weight on your shoulders of having to perform. The conditions you're going to be racing at, travel, everything else, and it's just nice to eliminate one more worry that you've got in your mind. So you're aware of how athletes push. You're basically hitting a hard glove, which is covered with rubber, onto a push rim on the wheel. You're coming into the push rim with quite a lot of impact, which obviously puts a lot of pressure through the wrists. It's kind of a punchy motion as you're coming onto the push rim. So obviously there's a lot of impact there, and as a repetitive movement, if you're a marathon athlete and you're doing it for an hour and a half, 2 hours, and obviously the training you're doing day in, day out, it's a lot of impact. And that's something else with 3D printed gloves is you could have a super stiff pair which you use for racing, which might give you that kind of fraction of an advantage, but play havoc on your wrists, and then have a softer pair which you're pushing day in, day out for training, which are fractionally slower, that allow you to train comfortably without causing injury. Yeah, the gloves have different pushing surfaces depending if we're in the dry or the wet. So in Chicago, I did the first lap on my dry gloves. Heavens opened, absolutely like monsooned it down, and I just dropped back into transition on the next lap, which was a detour. But I had to pick my wet gloves up and get going again because I was just losing so much time because I wasn't able to push. So traditionally you have two sets of gloves, but as I said, you can't make two exactly the same, and everyone's got a favourite pair of gloves. Whereas actually now with 3D printing and scanning technology, you can have as many pairs. I think I've probably got about 12 pairs of my gloves at the minute. Just print them off, and we've got them at various weights, and it's just nice to have the flexibility to be able to play, and just know that you're guaranteed that you've got several sets of gloves which are going to fit exactly the same when you put them on. You can't really buy racing wheelchair gloves off the shelf anymore. They're all individually, like most people are individually making them themselves, which is an art in itself, and not everybody's going to be able to do that. So that obviously offers up a great window. But as far as I'm aware, I'm not sure of anybody else that is offering the bespoke nature of the service in terms of, if you've got a racing chair glove, I will scan it and replicate that for you. And I know that there's nobody else doing the hand grips of the bike. That was my idea. Nobody else is doing that. But yeah, it's the real bespoke nature of it, which not just having something that's generically sized up and down again, something that's purely bespoke made to you. 3D printing just appears it is the perfect technology for it right now for printing lightweight, strong parts, which can easily be replicated in a very short time frame. I know with most of the gloves which are available on the market, they're most likely made out of ABS or PLA or a PETG, and I've seen several pairs breaking, and I've had people coming to me which I've made gloves for. But yeah, to be able to get on the Mark Forged and have that level of print quality and strength, it's just a game changer, another step forwards, and hopefully be able to create grips and gloves which are pretty much going to last indefinitely, unless someone crashes the bike, for example, or runs one over in the car. One of the biggest things, well, for myself and a lot of athletes I know, is shoulder health. Well, us guys and girls, we're using our arms literally all day, every day for everything. I mean, if your bike's set up and you've got a crank arm which is slightly too long for you, the results can be catastrophic. I mean, I had shoulder surgery back in 2014. I had my shoulder reconstructed, and that was predominantly down to spending years and years not being correctly set up on my bike. Basically, the only real difference between this and standard crank arm is the Q angle. So basically, the offset that the pedal or the hand grip is in comparison to the crank. So a standard road bike or mountain bike crank only has a very minor Q angle as the offset. You think if you're doing 100 revolutions a minute for hours and hours and ends each week, just slowly grinding away, slowly overreaching, sort of straining cartilage or straining the musculature, which is trying to hold your shoulder in place, which is a lot more complicated than hip joint, then people can develop problems. So again, everything comes back down to bespoke nature, and unfortunately with adaptive equipment, things literally have to fit like a glove for athletes to get the most out of them. Yeah, I mean, structurally, the big thing with these cranks is going to be the kind of torsion running through the crank. Obviously, you've got the hand grip or the pedal, which is going to be creating that twisting motion down the centre of the crank. So I think a lot of it's going to come down to layering the carbon reinforcement in to be able to. You've got the strain of the part twisting, as well as you've got the rotational strain of the spider at the top where it mounts onto the bottom bracket axle. So it's getting loads and forces applied to it in several different directions. So it's just kind of printing it in the best position possible that you can get the reinforcement running in the right planes to give it the correct strength and stiffness. So the grip you guys print to me is brilliant. The quality that's come out of it is fantastic, and I haven't broken it yet, which is good. So you guys printed me some prototype crank arms for the bike, which I've been and broke all of them on purpose for a testing point of view, just testing the kind of the strength of what I'm going to be able to achieve with your print. But I'm really reluctant. I love the grip, so I really don't want to break it. But yeah, I mean, with the Mark Forge, especially, it just opens up a whole new product line of what can be created. Being able to print parts which are lightweight, incredibly strong, and can be manufactured as one-offs relatively easy is a huge step forwards. I just come back to the kind of individual nature of disability again, and most things that are custom made for bikes tend to be welded out of aluminium because they can be reasonably bespoke, kind of made to measure relatively simply. But then you tend to get parts which are relatively heavy and not aerodynamically nice into the wind. And to be honest, they don't look great either when you've got a really expensive, nice racing wheelchair and you just got a bit of aluminium tube hanging off of it. It doesn't look the best, but yeah, with something like the Mark Forge 3D printer, I can replicate those. I can tune them to be aerodynamically efficient into the wind, which is going to have a performance advantage, especially when you're travelling upwards of 30, 40 mile an hour in a racing wheelchair going downhill. You want to be taking that aerodynamic advantage. Yeah, it's just a way to kind of push the sport, push the equipment on. So I've got some of the wind tunnel testing. There's quite a significant advantage of raising the back of the bike up a couple of degrees. Yeah, so yeah, we got that out of some of the wind tunnel data. So I've created some risers on the back of my bike. And currently, I'm basically using a parallel bit of steel tube, steel clamp, which weighs nearly as much as the bike. I've been using it for about a year now with training a bit. And yeah, it's perfect. It's doing the job, and I wouldn't race on that setup, obviously because of the weight penalty. Because yeah, I believe that it'll be amply strong enough to go on the back there. And I can create an aerodynamic shape, so almost like a teardrop profile to kind of clean the airflow off as it comes around the back of the bike. And a huge weight reduction as well compared to what I'm running at the minute. The clamps that I'm using now are adding nearly a kilo of weight to the bike, which is absolutely huge. Bear in mind the bike weighs 11.5 kilos, which is not light, but it's fairly light when you see the size of the bike. In fact, it's got 3 wheels, and there's a lot of carbon fibre there, so it's a huge percentage. And again, I've looked to get the parts machined, and it's just colossally expensive. Whereas 3D printing can have the part made significantly cheaper and achieve those kind of aerodynamic shapes, those smoother shapes, which when you're having things machined, the machine's obviously got to do a lot of work, it's got to run a lot of angles, and it just keeps bumping the price up of what you're trying to achieve. The rise at the back of my bike, I was quoted over £600 and 8 weeks lead time, I think, which is massive. And as I say, that's for a first attempt. Whereas you can 3D print them for reasonably cheap. As I say, just do a test piece, and then if you know it works, then you can go full carbon through it and spend a bit more money on the part. But I mean, it's just easy to adapt the file, and you can get it within a day. Just stick it on overnight and wake up the next morning and your part's there. Yeah, I think just being able to kind of fix captive nuts and put threaded parts in. So the design I have for the riser, the wheel screws into what we call a boss. It's a bit of aluminium tube, and what that allows us to do is the wheel's got a camber on them. As we rotate the part back and forth, you can adjust the toe in, toe out of the wheels. So you always want to have a bottom there to do that, to be able to make sure your wheels are running dead straight. It's really hard to make a part and then for your wheels to just work perfectly and always work perfectly. So yeah, being able to have an inserted thread which you can put in mid print, and then have a clamp which goes around the boss. Yeah, it's a nice tidy fix. I think, and at the end of the day, that's why 3D printing is so beneficial, is because it's such small production runs in comparison. Obviously, Trek or Specialise or something like that is going to ship so many thousands of bytes that they can pay for that R&D time. But when you're only shipping a couple of hundred hand bytes or whatever a year, it's hard to spend that amount of money.
I'd just like to thank Joe for taking the time to have the conversation with us, and I hope that you all found the content interesting. It's certainly been interesting for ourselves to run through Joe and see how we can assist with the Markforged printer. Hopefully, we'll be able to see him and the bike with all the Markforged printing components on it at the Olympics next year. Thanks again, and if you have any more questions, please feel free to let us know in the chat. Thanks.